We know AI can learn. But what is the scientific engine that actually drives that learning?
It starts with the perceptron. It takes multiple inputs, sums them up, and uses that result to make a decision.
That decision is governed by an activation function, which determines if the neuron's signal is important enough to pass on.
Each connection has a weight that amplifies or quiets the signal, and a bias that fine-tunes the neuron's output. The network's goal during training isn't just to be right, it's to minimize a loss function, a score that measures how wrong it is.
You can visualize this loss score as a landscape. The goal is to find the lowest possible valley, representing the lowest error. To do this, it uses a process called gradient descent, essentially feeling for which direction is downhill to reduce its error. It then uses backpropagation to send this error information backwards through the network. This tells each individual weight exactly how it should adjust to help lower the overall error score. After millions of iterations, the weights are optimized, and the network becomes a highly accurate, trained model. Specialized architectures exist, like convolutional neural networks, which use filters to become masters of image recognition. Recurrent neural networks have a form of memory, making them perfect for understanding sequences, like human language. So, a trained network isn't a set of instructions. It's a complex, dynamic model of knowledge derived entirely from data. This process is the scientific foundation that makes almost all of modern AI possible. What deep learning topic should we deconstruct next? Tell us in the comments, and subscribe to AI Academy for more.